Hello, I'm Thomas Hall, Executive Director of CleanStart. We're going to do today's perspective a little bit differently because there was a great discussion between Gary Simon, founder of CleanStart, and Mark Petersen and Mike Cioce of Legend Power Systems. We're going to let Mike Cioce give a quick disclaimer because Legend Power Systems is a publicly traded company, and then we'll jump right into the discussion between Mark Petersen, VP of Engineering, and Mike Cioce, VP of Sales and Marketing.
Excellent. Thank you very much, everybody. Greatly appreciate your time. Just a couple of quick housekeeping items. Legend Power is a publicly traded company on the Toronto Stock Exchange. Please visit our website or the cedar.com for current management discussion and analysis, as well as the fact that today we may include some forward-looking statements, so we want to make sure that we cover off all of the legalities properly.
Yeah, thanks very much, guys. Great presentation. Fairly familiar with auto transformers. You've got on here utility incentives under your KPIs, Mike. So are utilities beginning to offer incentives for people to install these on buildings, or are these incentives for putting equipment on the grid?
Yeah, so all of this is building side installations. So most of the programs that we were involved with have a custom measures program. And through the custom measures program, we're able to, because we do have an IPMVP compliant measurement and verification process. Because what's unique about the platform is we're able to, the natural state is off, which the natural state of the grid is passing through. And then when it's active is when we're adjusting it. So we're actually able to toggle between on and off, so to speak, in 15-minute increments, and then do that for a week or two, combine those two side by side, and you can see what the energy savings is. So yes, through a lot of the custom measures incentive programs, but through utilities on the customer side.
So the device you're putting on buildings is itself going to have an efficiency? Because if you're doing the conversions through an auto transformer, you get involved with what's the efficiency of the transformer. Yes. So what are the losses in energy across your system that you're installing on buildings?
Yeah, that's a great question. So running at full load, the system is better than 99.5% efficient. And the number seems really high, but it's because it's an auto transformer based system. So you have to remember that max 10% of the energy is actually being converted and transformed and going back again. The other portion of it literally passes straight through the device. With that, though, the other thing I'd mention is the savings results we're talking about, 4.2% portfolio average, et cetera. That includes the losses of the device. So that's net after that. Does that make sense?
Yeah. Yes, absolutely. But I mean, that's an important point.
Yeah.
I'll emphasize that to the people that are watching here online and on YouTube and Facebook. You're only affecting a small amount of the flow in order to do the compensation to get the score up.
Yes.
Yeah.
So while we see in your cabinet that you put on there the cooling fans and all that, which are parasitic loads, it isn't actually that much.
Yeah, and it's actually you've nailed something. It's a really key point, because there's other products that have a similar function, but the topology is very different, where they convert all the power. And in that case, you're looking at efficiencies that are probably in the 90 to 95% range. And with that, there is no energy savings. You're actually going to be a net consumer of energy. You'll have really clean power and good protection, but you're going to consume energy and pay for the privilege of having that. And I've been with Legend for 12 years, and when we sat down and, did the architecture for the technology, we started off with that. And that's why we've gone this auto transformer technology route, because we're looking for a solution that can improve power quality, address major issues, but also provide energy savings for the vast majority of buildings out there, rather than being a very niche solution for industrial applications.
Right.
So we've kind of taken a different spin on it, but the efficiency is the key thing, and you've nailed that with that question.
Yeah, because I think there are systems out there and people are marketing them that are the true double conversion systems, and that's where you get to the 5 to 10% energy loss. So there's a big distinction over what they're doing versus what you're doing.
Yeah, and also, with that, if that's the solution you have, the footprint, that system is like, our system is, roughly the size of a refrigerator you're trying to install into electrical room. Solution like that is the size of an SUV. So that leads to higher install costs, footprint,
Right.
and just the system costs themselves are significantly higher because you're just buying more equipment.
Right. Well, I would expect over time that the utilities, the operators of the grid, will be doing things on their system to compensate for this, what you establish as a poorer score. But it's going to be too expensive for them to eliminate it, down to the levels that you're talking about.
Yeah, you bring up a great point. And when you look at, for example, a lot of the utilities today do conservation voltage reduction during their peak periods. But at the end of the day, they are very limited because of the diverse nature of their distribution network.
Right.
So by doing it at the building level, if you do it at the grid level, you're using a chainsaw. But when you're doing it at the building level, you can use a scalpel and do exactly what's needed, or make the exact adjustments that are needed. So at the end of the day, the building is the right point to do it because of all the challenges across the distribution system.
Well, and given that, I would expect, the utilities or the ISOs to give more incentives to people to install this on the buildings. It is probably the cheapest way to deal with the problem because it's right with the end user that will benefit from it. But it benefits the grid too. It means they don't have to put so much equipment on to try to solve it at the bulk level. Do you see any movement towards greater incentives, either out of the utilities or the ISOs?
I think so. I think we see, we've had some really good conversations with a number of different organizations, and certainly where we have more systems based, I think we see a trend towards that. I think the one thing that works against us in that way is, utilities, they're great, but they tend to be slow moving, right? The pace that they roll out equipment, they're thinking 10, 20-year plans. We tend to try and function at the speed of business, right? And move quickly. And rather than waiting for a utility to solve this problem, I think there is a model though, Mike, and I don't know what you think about this, but with us working hand in hand where, utilities can have the big sort of paintbrush in the background and we can help, with the sporadic areas that are problematic for them. So it works well together.
Yeah, we are talking to a couple of utilities that are actually considering a premium power offering, where they're putting this into a rate base that goes into and then the equipment goes into the building. So therefore, the customer is getting the benefits of it, but they're paying it through a rate base.
That's cool.
Yeah, which should bring the cost down to the consumer. So, yeah, I could see that this would be a good thing for the utilities to get involved in.
Yeah, and I think that also, as if you look at most of the incentives the utilities are offering today are based on energy efficiency, but we're starting to see more grid interactivity and grid edge technology that can benefit the grid as well as buildings in the end. So I do see more utilities either expanding the custom measures option or embracing other grid edge technologies as well.
Now, one thing that when I had talked with Bob that kind of stood out to me is that, so you're increasing the power quality, which makes things basically work better and last longer. And it kind of occurs to me in a lot of the different neighborhoods, you have a lot more older technology and older things, and you have residential on there as a place where you can, or as like, I guess, an adjustable market. What are some of the ways that you guys can impact, I guess, residential and when it comes to, I guess, quality of life? As in,
that's a great question. Right now, our focus is on the multifamily residential. We look at either condominiums or apartment complexes where we can have a cost-effective solution that addresses a large number of residents. We're seeing dramatic gains for those residents. From the standpoint that they're not only seeing lower power bills, but they're also seeing better power. They're everything in the building is lasting longer. Is more reliable. And we're working right now with a building owner in New York City who's having some challenges with their elevators, and again, a 60-story apartment building that has elevator problems because of power problems.
Mhm.
So solve that power problem, solve the elevator problems, and then you're increasing the quality of life for everybody in the building. You
No
know,
one wants to get trapped in an elevator.
yeah, exactly. You know, and especially when you look at all of the more advanced a system is, the more sensitive it's going to be to voltage fluctuations. So whether you're looking at a life and safety system, a security access system, HVAC system, lighting controls, all of those can be negatively impacted by the power. So it's just what we're trying to do is we're trying to make sure that everybody understands that this is coming and that you can get out in front of it now so that you don't have people that are negatively impacted because of the challenges inside of the facilities that they depend upon.
So do you see any of the, companies that do HVAC, heavy equipment? Do you see them wanting to approach potentially Legend or looking at ways to solve this on their new equipment? Or is it something that they figure that you're seeing them just kind of ignore and let someone else handle?
Yeah, there's a great interest across a variety of those types of companies. We're in active dialogues with several of them, so it's going to be very interesting for sure.
I would expect that some of the companies trying to install renewables plus battery systems for larger customers, whether it's multifamily, residential, or commercial, would be natural allies to add this product to their install. Have you found interest among those vendors?
Yeah, absolutely. In fact, about a year ago, we actually went to the capital markets and raised some money to fund our growth through our channel markets. So earlier, actually probably about 6 months ago, we hired someone to focus on channel markets. So that's everything one from traditional energy service companies and performance contracting organizations to distributors, resellers, electrical contractors. And the response has been very tremendous, because at the end of the day, especially companies that are focused on energy efficiency, everyone's got the LEDs now. What's next?
Yeah. Well, I think the channels, great thing for you to be exploring, because they are confronted with the question when people say, well, what do I do if the solar isn't reliable, or I've got a wind farm and it's going to be intermittent and that's directly connected into my plant. How do I deal with this?
Absolutely.
They're there at the, as the military say, the tip of the spear, where the concerns are coming up.
Exactly.
Well, that's just, it's a great job you've been doing. Now, when did you guys found the business and get started on this? How long have you been
I'll
pursuing?
let Mark cover that off. He's been here longer than I have. He's been
Yeah,
here.
I mean, the business is probably, I think, about 14, 15 years old. I've been leading the technology team for the last 12 years. And, the reality is that the first, probably 8 years of that were really R&D technology development. And then the sales launch was really in the last 4 to 5 years. We mentioned 300 plus installations across North America, large presence in, office, classroom, multi-residential has been really good for us. Big box retail, commercial buildings, really, any buildings with people in it. We do low voltage. We don't get into medium voltage services unless we can tackle it after it's stepped down to a low voltage side. So 208 volt, 480 volt. And growing and increasing footprint with a lot of household names, really.
Yeah, well, I would expect like grocery stores would be a very important market for you, given the number of motors involved in a typical grocery for refrigeration. So, yeah, I think there are huge markets out there that you can still develop in your channel.
Yeah, no two ways about it. What's also interesting is when you're looking at the fact that heating is a massive component to greenhouse gas emissions. And as people are moving towards electrical based heating equipment, those loads are very responsive to conservation voltage reduction. So we can actually have a very favorable impact on the cost of electrification for people that are looking to move to electric heat.
Yeah, no, it's just a question in my head. I haven't gone through the technology, but one of the other big trends that we're tracking out there is vehicle to home and vehicle to grid, for which you're going to need a bidirectional inverter. And done well, that inverter can deal with some of the problems that you've raised here. Done the way it's typically being researched, it won't. Have you looked at sort of the emerging market? And it's tiny now, but there's so much interest behind it. I'm thinking it's going to grow pretty big in integrating vehicle to home, vehicle to grid, in the midst of what you can offer here, because it might solve part of the problem, it might cause part of the problem.
Yeah, it's something that we're keenly aware of, and we're looking at from a couple of different angles. That there is some natural points of integration with the existing technology we have when you start looking at vehicle to grid and back and forth. That there could be some really creative ways to tie it in, either at a surface level where you're looking at almost just like from an installation perspective, and in some of the things that we can leave some of the hooks physically to tie in to it later, or at a deeper technology level because we have a DC bus within the unit that we could tie into. So it's something we're aware of and we're looking at as we go forward.
Yeah, and that brings up a great point, because the thing that Mark and his team have done a phenomenal job, and I can go ahead and do this horn for them. They've done a great job of making sure that this platform is extensible. So with the SmartGATE that we have today, it's going to serve as the central hub for electrical distribution inside of a building for decades to come, because we can continue to enhance that, continue to add features and functions to that because of the components and the topology that Mark and his team have developed.
Yeah, I think that's very important, because we all know that the grid is going to evolve and there's going to be more stuff that comes into it, and it'll have impacts on the grid that nobody's paying that much attention to right now, which I think is becoming obvious to a lot of people as they move down the path to be using more intermittent resources. So what are we talking about in cost? You're relatively low voltages and current, and you're right up there with the building. So, you have let's see, you had a 345 or 365 volt system. You had, 200, 400, 500 amps. What's that going to cost somebody to install in rough terms?
So there's a couple of factors that go into the pricing. First is the size of the system that's needed, and that's based on the load of the building. So again, as Mark mentioned, we go from 400 amps to 5,000 amps. So it depends on, that's the first trigger. So the equipment cost is anywhere from $40,000 to $150,000, depending upon the size of the system. Obviously, if we're going into a large commercial building, that's going to need a much bigger system, much more expensive system than something that's going to be going into an elementary school per se. So again, 40,000 to 150,000 on the equipment side, and the installation, it varies based on the complexity of each individual install. A general ballpark is going to be between 50% of the cost of the equipment to 200% of the cost of the equipment for very complex installs.
Yeah, but what you're talking about there against the savings, I mean, I'm sure you've done the calculation, but quickly in my head, that sounds like it's under a 5-year payback.
Yeah, it's interesting because early on we were that's how we sold. We would go and talk to customers and say, it's going to cost you $100,000. It's going to save you $20,000 in energy, so it's a 5-year payback. And one of our customers actually took the time to educate us and explain to us that it's actually closer to a year payback when they look at it, because what they were actually doing is they were saying, okay, yes, it's going to cost $100,000, but we're going to take advantage of accelerated depreciation right off the bat, which is going to save us $30,000 in taxes.
Right.
We got $10,000 coming back from the utility, so our cost base just went from $100,000 to $60,000. And not only are you saving $20,000 in energy, but you're also saving us $20,000 in maintenance and repairs of the facility. But also now that the facility is a little bit better, they can charge a little bit more and get a little more income out of it.
Right.
So what they're actually saying is that that was about another $20,000. So what through the incentives and through the tax programs, they brought that down to a $60,000 base with $60,000 of recurring benefits. So not only did it pay for itself very quickly, but also that $60,000 was a direct increase to net operating income for this operator, which the valuations were for them were about 15x. So every dollar in profit was worth $15 in valuation. So we just increased the value of the building by about $900,000 as well.
Right. Well,
so, yeah, it all comes together to very powerful financial performance.
well, that's the virtuous circle you're going to get into as you have more cases that you can document what the savings were. It's more convincing then to a potential customer that they can add that into their calculation. But sure, if you're down to a year or two payback, that's going to have a dramatic push behind it, and people are going to be very interested in it. So that's interesting.
That particular customer's already bought north of 50 systems, and they're considering another 20 more.
Yeah, that's great customer feedback, and obviously they're quite happy. Thomas, are you seeing more questions come in from those that are watching on other platforms?
We have about 25 active watchers right now, so that's pretty good for just starting this, but no questions.
Okay, well,
answering them all.
If people are out there having more questions, put them in our chat or put them in the systems that you're watching it over. But gosh, this has been such a great education. And as you say, something that people don't ordinarily pay attention to. Now, I've been a senior utility executive, so I won't take umbrage at how you characterized my colleagues, because we all joked in the utility business, the preferred method of suicide is for a utility executive to stand in front of a glacier. So says something about how slowly things change. So I know a bit about what you're up against. It's really good to see that people are paying attention to this. It's been a problem for a long time. I mean, going back to the old days of just power factor correction. It's just that it's only until now, I guess, it's big enough for people to pay attention to.
Yeah, it's big enough for people that can pay attention to, and the technology and has developed to the point where we can do immensely more. Mark and his team have just built such an amazing platform that not only does it actually correct the vast majority of these issues. You know, we're going to take 90+% of the power issues that are entering a building, just going to take it out of the building altogether.
Yeah.
But what we're also able to do is turn that power quality into an IoT data stream. So now you can stream this data real time into your building management systems. So that if you want to set up any type of alerts, and it's also the system is also we're able to adjust it kind of like you do a Nest for your HVAC system. So if you have a demand response event and you want to say, let's try 455 today instead of 465, you can turn it down and have the benefits that go along with that as well. So it's a fully tunable system. So
interesting thought there that I hadn't considered. So where are you located? Where's your headquarters?
Yeah, our headquarters is in Vancouver in British Columbia. We have sales offices in Toronto as well as New York.
Got Bob here locally too.
Mm-hmm. Yeah.
Well, there was a big inverter company in Vancouver. Can't remember the name, but they got very successful. So, yeah, hotbed of innovation up there. We appreciate your joining us, and good to have Bob more local on it. But from everybody that's out there, round of applause to these guys for what a great presentation and the information they've provided us all today. This is just hugely important. So Thomas, let's turn it back to you.
All right. I would like to thank Legend Power Systems, Mike Cioce and Mark Petersen for joining us today. A shortened video of this will be made available on our YouTube channel. Additionally, it'll be on LinkedIn and our other channels that we have.
Plus, we'll be doing a blog on this, short one to sort of summarize the conversation today and point people to watch the entire video if they want more information. So
check out cleanstart.org for that. Also our other media channels. Thank you for attending. Stay connected with us. Hope to see everyone at Sacramento's Clean Tech Showcase on April 12th. I want to thank our sponsors for their support, SMUD and Blue Tech Valley, along with additional sponsors from our overall programs, including Hacker Lab, Reverent Video, Moss Adams, GT Law, and Weintraub Tobin. And with that, I'll conclude our broadcast. Thank you very much.
All right. Thanks, gentlemen.
Thank you
Thank
all
you.
very much. Greatly appreciate it. It's been a pleasure.
Absolutely. Loved it. Yeah.
Great.
All right, great. Yeah, so appreciate everyone's time. We'll try to keep this to about 10 minutes today. Again, want to give you an overview of the current state, what makes Legend Power innovative, and talk a little bit about the performance of Legend Power. From a high level, from a current state standpoint, most people are aware of the fact that utilities do a great job of staying in the accepted ANSI standards for power quality. So what that means is that there's a range that's acceptable for most facilities on a 480 volt service. That's going to be anywhere from 445 up to about 510 in that range. The challenge is that as you get further away from the nameplate rating on equipment, the efficiency starts to go down, the reliability starts to go down, and the lifetime of the equipment starts to get impacted as well. So while the utilities are staying in that range, what we're seeing is some challenges for buildings to be able to actually ride through this. And that's the traditional power quality paradigm. And what Legend Power really focuses on is, rather than staying in that power quality range, what we'd like to do is, we call it optimal power paradigm, where if the nameplate rating on a piece of equipment, most of the equipment in the facility is 465 volts, we can maintain that in a very tight, fully regulated environment. And by doing that, what we're able to do is actually increase the efficiency, the reliability, and the lifetime of virtually everything in the building. So that's a big differentiator for us, is that we have sizes that range from a small building up to the largest office tower. So we're able to handle a wide variety of buildings. And the reason why this is more important than ever is that when we all know that we're in the process of electrifying and decarbonizing everything, right? Especially on the grid. We're moving away from fossil fuels, going to more wind, solar, batteries, and distributed energy resources. The challenge that we're going to see over the coming years, as we make this needed transition, is that we are going to see some of that instability go up, which means that that power range that we were talking about, the ANSI standard, we're going to be operating more to the edges of the bands, which is going to make it potentially harder for buildings. And because of that, that's going to increase the instability and the impact of buildings. And that's what we're here to solve. We're here to make sure that buildings have a great ability to ride through some of these challenges. And again, when we look at kind of what our take is, we look nationally, we're under 10% variable renewable rates. What we're seeing, we have a scoring methodology that Mark's going to talk about in a minute, but it shows that our national average score is about 7.2. If we zoom into the areas where we have greater than 10%, but less than 20% variable energy, we see our scores drop off the cliff down to a 5.2, and that falls into the critical range. And again, Mark will cover that off in a little bit. But if we go to areas where we have greater than 20% renewables, again, we see that that efficiency, reliability, and lifetime score fall off the cliff again to a 4.1. And this is what we're here to talk to you about today, because with active power management, what we can do is we can protect individual buildings from that instability and be able to make sure we're delivering that fully regulated power supply all day long. Okay, so with that said, I'll turn it over to Mark, and we'll talk through the platform itself.
Great, thanks, Mike. So as we talked about, if we're discussing, commercial building electrical services, we'll talk about it on a 480 volt basis for today. We know there's huge variation, day to day, week to week, hour to hour, really, depending on grid conditions, weather. Look at the events we saw last couple of years in Texas and things in California as well. Power can be better than that. So really what Legend does first is we strive to understand what the power looks like. We have a two-part solution where we document it first and measure it. But a SmartGATE system essentially sits in series with the main feed to the building. and provides complete voltage regulation. So we have the ability to reduce the voltage, we have the ability to boost the voltage. We do that on a phase-by-phase basis. So we're able to actually implement some phase balancing and pull them together, and really gives you a complete regulated and controllable power supply for the entire feed, whether it's a 208 volt feed or a 480 volt feed. Doing that allows us to significantly increase the energy efficiency of the end use equipment, making sure it has the exact voltage it needs to perform at its best, as well as increase resiliency, uptime and lifetime of equipment, lower greenhouse gas emissions, all the benefits that come from, controlling this power, making sure it's as stable as possible. The system itself, Mike, you want to flip to the next slide, again, sits in series with the supply of the building. I mentioned we do 480 volts, we do 208 volts, and anything from about 400 amps to 5,000 amps is so most commercial electrical supplies. It's an auto transformer based system that allows us to, get to the exact output we want. And that's essentially the short version of the story. Mike, do you want to grab it back?
Yeah, excellent. Yeah, so again, as we talked about earlier, we do have a scoring methodology where what we do is we actually hook up power quality monitoring equipment for a couple of weeks. We gather all of that data and we run it through research that's been done by ANSI, IEEE, EPRI, those types of organizations that are peer-reviewed, published research that say when these conditions happen, here's the impact to typical types of equipment. So we're able to take that raw data and combine it with that research to be able to come up with a score. And when we see those scores greater than 8.5, that means you've got good power, there's minimal operating waste, equipment should last as long as expected. And the 1 or 2 events per month, or call it 24 per year, that are hitting, the building has a high ability to be able to ride through that. Conversely, once we get into scores of 5.5 or lower is where we get into the critical range. That's where you've got energy waste of greater than 4%. You've got a degradation of the life expectancy of equipment by greater than 20%. In addition, that the number of events that are happening are double what the systems can effectively ride through, which means that the ability to be able to ride through that is greatly diminished. And again, when we look at the fact that as we make this absolutely needed transition to more renewable energy sources, this is our opportunity to get out in front of it as an industry, to be able to make sure that people understand that they have the opportunity to be able to do something about what's coming, what's heading in their direction. When we look at how prevalent this is, right now we're finding only about 10 to 20% of the buildings falling into the good range, about 20 to 30% falling into the critical range. And so that means over 80% of buildings are negatively impacted, and that's today. Again, as we start to get over into the double digits and into over 20%, look at our national average. Our national goals are to be at 30% variable renewable by the year 2030. That's going to put us in a situation where the majority of buildings will fall into that critical range unless the building owners take action and prevent and take steps to be able to prevent that from coming to their building. So again, this impact report, what we're able to do is aggregate all of this information together to be able to show what the current state is, what the future state is. We can actually break down on a building by building basis based on the incoming power, what the scores are, what the energy waste is, what the impacted life expectancy, and as well as those number of events that ultimately affect the reliability of the equipment. But what we're also able to do then is to take those KPIs and to be able to show the true cost of power, because it's more than just what you're paying on your electric bill. Obviously, if you have a 20-year asset that you're expecting to last 20 years, that's only going to last 15, that's a cost to an organization. And being able to identify that ahead of time and be able to operate that and affect that, there's a lot of benefit to that. Additionally, we work with people across the industry. For example, even with LED lights, the manufacturers know that when they have poor power conditions, the 3-year failure rate on equipment, on LED equipment, can easily be approaching 20% or more. Conversely, where they have good equipment, it's low single digits. And again, you just cascade that across all of the building systems, and that's really where we can help identify what those risks are, and then again mitigate them out of the business altogether. So if we look at a high level, again, we've got over 300 systems installed across North America, and everything from big box retail to elementary schools to multifamily residentials to airports to office buildings and everything in between. You know, right now our portfolio average for energy savings is about 4.2%. We also have our average maintenance savings is approaching 18%. So again, we've got a great track record of really driving this home for a lot of value for our customers. So with that said, that covers off the presentation portion. We'd love to switch over and see if anybody has any questions.